Welcome to another edition of Physics Videos. Our topic for today is the second law of thermodynamics. The second law of thermodynamics describes the behavior of an isolated thermodynamic system. There are three different types of systems. The first type is called an open system. In an open system, both energy and matter can enter or exit the system. An example of an open system is a classroom with the door open. Students, representing molecules of gas, can enter or exit through the door. Energy can also enter or exit through the door and windows, depending on the difference in temperature between the room and its surroundings. The second type of system is a closed system. In this case, no particles may enter or exit the system, but energy can. An example of a closed system is a can of compressed air, or a classroom with the door closed. The contents may not enter or leave the system. However, energy can still be transferred in or out of the system. The third type of system is an isolated system. In this case, nothing can enter or leave the system. This means no energy can enter or leave and no particles can enter or leave. Isolated systems are the hardest to create. They must be well insulated to prevent energy exchange, and they must be sealed to prevent particle exchange. The ultimate isolated system is the universe. Now that we have defined the three types of systems, let's look at what the second law has to say about isolated systems. The second law states that the entropy of an isolated system can't decrease. The most important thing to remember, here, is, the system must be isolated. So, what do we mean by entropy? Entropy is usually defined as the amount of disorder in a system. By disorder, we don't mean how neat the system is. Instead, we refer to the distribution of the kinetic energy of the molecules. A system with high entropy will have a large distribution of Ke and molecular speeds. It will be at a high temperature. A more ordered system, one with less entropy, will have a smaller distribution of molecules. It will be at a lower temperature. There are many different ways to think about the second law. Suppose an isolated system consists of a hot cup of coffee and its cooler surroundings. Over time, the cup of coffee will become cooler and the surroundings will become warmer. Does this violate the second law of thermodynamics? The coffee loses some thermal energy to its surroundings, and the surroundings gain the same amount of thermal energy. The entropy of the coffee decreases. The coffee by itself is not isolated. The increase in entropy of the coffee is offset by the gain in entropy of the surroundings. When we look at how entropy is calculated, we will find that the gain in entropy of the surroundings is actually larger than the decrease in entropy of the coffee. So, the total entropy change of the system is positive. The second law is fine. The second law states that the change can't be negative. The second law predicts that when left to spontaneously interact, the coffee will not become hotter and the surroundings cooler. The symbol we use to represent entropy is the letter S. For small exchanges of thermal energy, the entropy change is calculated as delta Q over T. The temperature is assumed to be constant. When the temperature changes, assuming a small change, we use the average temperature. For our coffee example, delta Q is negative because the coffee loses thermal energy. This occurs at a high temperature. For the surroundings, delta Q is positive, the temperature increases and this occurs at a lower temperature. Since delta Q has the same value for both the coffee and the surroundings, the entropy change at lower temperature will be larger. This guarantees a positive total entropy change. The key thing to remember is that the system must be isolated. Energy can be exchanged between parts of the system, but it can't enter or leave the system. That's the second law of thermodynamics. We'll see you in the next edition of physics videos.
Ciao, bella!